Hello everyone. In this video we're going to be solving an interesting equation. If you like this video, please comment, subscribe and hit the bell button for notifications. If you don't like the video, let me know why in the comment section down below. I appreciate all kinds of feedback. Thank you for watching and let's get started. Alright, so we have this interesting equation with three variables, x, y, z, but we're going to be solving it for x. So in x, this is a cubic equation, and you know the cubic formula is complicated enough, even with numbers, let alone variables. So what we're going to do is we're going to manipulate this equation a little bit to make it more manageable. All right, let's get started. Now, the first thing I want you to notice is that we have some fractions, and there's a z in the denominator. And obviously, we don't want z to be 0. So let's go ahead and write that down. Z does not equal 0. And with that condition, I can just go ahead and multiply both sides by z. So therefore, we're going to get rid of the fractions. So we'll get zx cubed minus yx squared plus z squared minus z plus y multiplied by x plus z squared minus yz is equal to 0. Okay, so this equation is still complicated. There's three variables that are all kind of mixed up, but again, this is a cubic in x and we want to solve for x. So here's what we're going to do. We're basically going to expand everything here, and then I'll show you the method and then we'll talk about it. Okay, so we get zx cubed minus yx squared plus z squared x minus zx plus yx plus z squared plus yz all equal to 0. Okay, now why did we distribute everything? So here's the trick. For this problem, it's very hard, probably like nearly impossible to solve for x. You probably need to use something like Wolfram alpha. And even with that one, it's going to be super complicated. So what we'd like to do is we want to make this equation, we want to turn it into a quadratic. And how is that possible? Well, it is possible because if you kind of pay attention to this equation, you're going to notice that this equation has x squared in it, x cubed in it, so that's cubic. But it also has z squared in it, right? So basically what that means is that I can write this equation as a quadratic in z. And how is that possible? Let's go ahead and do that. So I'll put together the terms that have z squared in them. Okay, so this one and this one. And then I'll bring the terms that has z in them together. So we'll get zx cubed here. We'll get negative zx here. Sorry, my z kind of looks like a 2, but there's a little line through it. So hopefully that'll be more clear. And obviously we have no numbers here. Everything is variables. Okay, do we have any other terms that have a z? Yep, we do. The last one is minus yz, last term. So we're pretty much done with everything that contains z squared or z, which means we end up with constants. And those constants are going to be yx minus yx squared. And again, this is equal to 0. Now, after doing this, what we're going to do is we're going to put together the terms with z squared. So it's going to look like x plus 1 z squared. And then these two terms can be taken out. Again, our goal is to write this as a quadratic in z. So don't focus on x, but more focus on z. X is basically constant here in this case. So we're going to get x cubed minus x multiplied by z. Oops, we forgot one term. Never mind. Back up. Okay. So these two will give us that, and then plus everything that contains z, x cubed minus x minus y multiplied by z. That takes care of the z terms. And then finally, we have our constant yx minus yx squared equal to 0. All right, beautiful. Now, my equation is a quadratic in z. And I can just treat x and y as constants and z as the variable and just go ahead and solve it. And obviously, you wouldn't try to factor this, would you? We're going to use the quadratic formula. But before we use the quadratic formula, I just want to tell you that plugging everything into the formula is going to be messy. So let's go ahead and find the discriminant. So let me call the discriminant, because you know that the letter D or delta, that's what we use, and it looks like a triangle, right? So our discriminant, I don't think that's how you spell discriminant. Let me go ahead and fix this real quick. Discriminant. Okay, here we go. Discriminant is equal to delta. So let's go ahead and calculate delta here. Okay, what is delta? B squared, right? B squared. And notice that when we say B, we're talking about the coefficient of Z here. So it's just the coefficient, okay? B squared minus 4AC, 4 times x plus 1 times C, which is yx minus yx squared. Obviously, even though this is going to be a little messy, I need to expand it and just simplify as much as I can, okay? Let's see what this turns into. So I'm going to square this. Square the first term, the second term, the third one, and then do the 2ab, 2ac, and 2bc thing. Minus 2x to the fourth minus 2x cubed y plus 2xy. I gotta be very careful here, right? And then this guy is gonna give me, let's see, negative 4 times. Okay, let's go ahead and distribute that. Yx squared minus yx cubed plus yx. I gotta be careful because the 4 is outside with a negative, so I'm only concerned about these two parentheses, minus yx squared, right? Okay, I think so. All right, so let's go ahead and arrange these terms a little bit, and so hopefully we can get something nice from here, okay? What am I gonna do? Okay, I gotta put together these terms in a meaningful way, and how am I gonna do that? Well, I'm gonna start with the highest power of x here, which is, x to the 6th power. Obviously, that's gonna go first, right? So I'm going to write down x to the 6th, and then I have, let's see, okay, this is what I'd like to put together. I have minus 2x to the 4th, so let's go ahead and go by the powers of x here. Minus 2x to the 4th, so I've taken care of this one and this one. I gotta keep track, right? That's super important. And then, which terms come with x cubed? Okay, let's take a look at that one. Well, I do have minus 2yx cubed, and then I do have plus 4yx cubed. And obviously their sum is going to be 2yx cubed, right? Positive 2yx cubed. Cool. That takes care of that. And then, do I have any other x cubed? No, I don't. So I've taken care of this and this one. Of course, with the multiplication of 4, that's included. And then I'm going to look for x squared. I do have 1x squared here. I do have, yx squared cancels out, by the way, inside the parentheses. They do cancel out, so that's kind of nice, isn't it? So I just end up with 1x squared then, a single x squared. Beautiful. That's good. Now I have to take care of x. Okay, and which terms have x in them? Now, if you take a look at this, we have 2yx minus 4yx. So that gives me minus 2yx. Great. I've taken care of this one and this one. Beautiful. So we end up with what? The only thing we have left is plus y squared. Awesome. Now, this is pretty good. And if you notice, there's something cool about this. Okay. I hope you get to see that, or am I looking at the wrong thing? Because what I see is looks like I can take out an x cubed or x squared. Let's see what happens if I take out an x squared. I do get an x to the 4th. Okay, let's just experiment. What's the harm, right? Let's just go ahead and try that. If I take out an x cube, I don't think it's going to be a good expression, but let me go ahead and take out x squared. This should give me x to the 4th minus 2x squared plus 2xy. Well, as it is, I don't think that's going to be super helpful, so I got to approach this differently. So let's see what we can do. Well, here's my goal. Okay, let me explain what I'm trying to do here. I'm trying to write this discriminant as a perfect square so that when I write the formula negative b plus minus the square root of delta, I can get a meaningful expression. Okay, and how can I do that? Well, if I'm claiming that this is a perfect square, so I need to have some, evidence, right? Well, my evidence is that first term is a perfect square, last term is a perfect square, and this one has 6 terms. So could this be the square of something like a plus b plus c, or x cubed plus minus something x plus y, maybe? Okay, so here's what we need to do then. If that's gonna work, it needs to go like this. I need to have plus, let's just say plus, and let's call this number b. So I want to assume that this is in the form x cubed plus bx plus y, and then it is quantity squared. Okay. Now, these are like two polynomials that are equivalent for all values of, x, y, whatever. In this case, it will be x, of course, because it's written in terms of x. Is that possible? Let's go ahead and see for ourselves. So if I square the second expression, I get x to the 6th plus b squared x squared plus y squared plus 2bx to the 4th plus 2yx cubed plus 2bxy. All right, that's going to be my expression. And I'd like to set this equal to the original one. Now, here's what I'd like you to notice. X to the 6 matches up, all right, here and here. Y squared matches up here and here. Let me put a dot so we can compare. And then everything else is like kind of coefficients, but 2yx cubed also matches up. Nice. And then what else do I have left? I have minus 2x to the 4th, which is 2b. So from here, I'm basically getting the expression. Well, I'm just getting the information that b might be -1, but we have to double check. Okay, so this seems to work with b equals -1 because of this term here, but we have to make sure everything works. Okay, if b is -1, this is going to be a positive x squared, which is correct. And then if b is -1, this is going to be negative 2xy, which is also correct. So everything checks out. Awesome, beautiful. Then this means that b is -1, which means our discriminant is equal to x cubed minus x plus y quantity squared. Beautiful. Now, this is my discriminant, so I still have to solve the equation, but the rest should be fairly easy, right? Hopefully. Now, what am I going to do? Where's my original equation, right? I arranged it as a quadratic in terms of z. So what I'd like to do is I'd like to take that equation and then write the solutions using the discriminant, right? So let me go ahead and cut this, right? Let me go ahead and cut it. And then I want to just move it down here so that I can use it along with the discriminant. All right. I think this looks good. All right. Let's see. Oh, we got some extra terms, but that's okay. We can delete them. Okay. Nice. Now, what am I going to do next? And these are also extras wherever they came from. All right, cool. Now, this is my discriminant and this is my equation. So what are the, by the way, we're solving for z here, obviously, right? Because z is the quadratic. So z is equal to negative b. Negative b is going to be the opposite of this. So you can negate it, however you want to do it. But I'll probably just do it, like this. Negative b. Plus minus, of course, we have to get two solutions from here. The square root of b squared minus 4ac. Oh, by the way, I forgot this is square root of delta. Okay, cool. Divided by 2 times a, which is 2x plus 2. I don't know if I should write the 2 outside, but anyways, doesn't matter. Big deal. All right, cool. So since I have the delta given in a nice way, I can just go ahead and plug this in, right? So that's my delta. Here we go. And now what I'd like to do is I'd like to bring it over here, right? I mean, just plug it in. Okay, so let's do that. So z is equal to negative x cubed plus x plus y plus minus. Now, plus minus, this is going to be square rooted, so it's not going to matter. And when you square root this, of course, I have to write that in parentheses because of the minus sign. It's going to look like this, right, with the plus minus sign, divided by 2 times x plus 1. Awesome. Great. So these are my z values. Let's go ahead and simplify this. Of course, there's going to be two solutions, so let's go ahead and split them up. So z1 is going to be, I don't have to call it z1 because I like it better that way. So let's just call it z, it doesn't matter. You want to do the positive first? Okay, fine. plus x cubed minus x plus y divided by 2 times x plus 1. So again, this kind of looks complicated, but don't worry, it's going to simplify. These two cancel out, right? And then we end up with, x cancels out too. Beautiful. Is that correct? With the plus sign, yep, it should cancel out. Okay, cool. Let's not make any mistakes because this is going to be real messy when we do. So this is going to be 2y over 2 times x plus 1, which is cool because the 2 cancels out. And that leaves us with z equals y over x plus 1. So let's leave it at that because I'm going to go back to it later and then, put it together. Okay, so that's one of the z solutions. Let's find the other z solution by considering the negative sign. Negative x cubed plus x plus y. Everything will be negated, so make sure you change that. Divided by 2 times x plus 1. Again, the 2, let it stay. So maybe we can just cancel it out, hopefully. Here, y cancels out. Nothing else cancels out. So it's going to be like then 2x minus 2x cubed divided by 2 times x plus 1. Okay, this will simplify a little bit more, but I think we should probably mention a couple things here, but anyway, I just realized that. So if I take out a 2x here, I should be getting 1 minus x squared, which can be factored as 1 plus x, 1 minus x, divided by 2 times x plus 1. I think I should have mentioned that x does not equal negative 1 in this case, because what I'd like to do is I'm going to simplify this. What happens if I don't? Well, the solution is going to be obviously more complicated. For simplicity's sake, let's assume that x does not equal negative 1 and we are allowed to simplify. So this just gives me another solution, doesn't it? And that is equal to z equals what? X times 1 minus x. So far what I have is basically I got two solutions for z. This is one of them, and this is just the other one. Where's the other one? Oh, it just disappeared. Okay, here we go. So these are the two solutions for z. But how do we use them? Well, we weren't trying to solve for z, were we? No. Okay, our goal was to solve for x. Remember, y and z are considered constants. But we took advantage of the fact that we can solve a quadratic much easier than a cubic. So what we're going to do now is we're going to solve for x. All right. How do we do that? Well, the first one is fairly easy. If you just go ahead and let me do the following. I'm just going to go ahead and cross multiply and write it down here. So zx plus z is equal to y from the first equation for z. And then my goal is to solve for x, remember. So from here, you'll get zx is equal to y minus z. And then if you divide both sides by z, then you'll get one of the solutions. So one of our solutions is going to be x is equal to y minus z divided by z. That's one of my x values, okay? The other x value is going to come from here. And how do we solve that one? Let's go ahead and split it up. And we're going to solve it this way. We're going to distribute z equals, this is my second one, x minus x squared. And then what I'd like to do is I want to keep the x squared as positive and put it all together. And here we go. Surprise! Quadratic within a quadratic. So this gives us another quadratic, and which we can solve very easily. X is going to be from here, negative b, plus minus the square root of b squared, which is 1, minus 4ac, which is 4z over 2. All right? So those are going to be the solutions. Thank you for watching. I really like this equation because it looks complicated, but it can be solved. I'll see you in the next video. Take care. Bye-bye.